The floor is yours.
Well, thank you, Tyler, and I appreciate you putting these together. What a great resource for all of you here to have a series like this that he's done. So really good and great to see it growing. So as we go through here, with this group, if you have a question, I'll stop different times for questions that are on the topic. It's a lot easier to do that. When we're doing it, we're just going to talk seedling disease, seed treatment. We're going to talk about sudden death syndrome, and we're going to talk about soybean cyst nematode. Okay. I'll tell you, I don't have any new data, I don't think, from last year, but I got some larger summaries from some regional data sets and colleagues that we've worked with that we're going to show as well, just to kind of give you that decision process or data to help you out that way. So these are our main 4 seedling diseases. Many of you have seen these as far as problems in your field: the Fusarium, the Pythium, the Phytophthora, the Rhizoctonia. Now, realistically, the Pythium is the most common, and with cooler, wet soil conditions, that's what we have. Those of you that know you have Phytophthora problems have a history of that in your field, usually. And so one of the things we always talk about is making sure that you're doing good diagnostics or identifying those problems so you can match things up appropriately as you go into the future, and you know the conditions that favor that disease or stand issue problem in your field. These are kind of the optimum temperatures for those pathogens, and you can see here, if soybeans optimum is around 60 degrees. So a lot of times why Pythium is so common is you're in that 50 to 60 degree window. So you got a really great conducive environment. That seedling slows down, and then you're going to have problems. Interestingly enough, those of you that have Phytophthora problems, remember, those are going to be a little bit warmer. So typically if we get in there and maybe things are coming up and you get heavy rains and warmer soils, that's when Phytophthora can really take off. Over the past several years, I'd say in this part of the state, we've seen several instances where maybe we've had a little bit of dry spell and then some heavy rains, and then Phytophthora kick off. That's stress of that plant being stressed, and then having that flooded soil conditions, release of those spores. They actually swim, those little spores, and then they can go on and infect. So that's one of the reasons you'll see it more common in that scenario with it. Here's just, again, kind of that overall symptom, but Rhizoctonia, you tend to get those little lesions right at the soil line. Phytophthora, you get that dark stem discoloration working up. And then Fusariums, when we talk about Fusarium as a seedling disease and we talk about sudden death syndrome, we're typically talking about two different species of organisms, grossly different. So it's not the same thing that we're referring to, but when you see this taproot discoloration in here, same thing you see with SDS, right? How many of you deal with SDS? Got some in here for sure. Pull those plants real easy, taproots rotted off. Same thing you see in the seedling stage if it's a Fusarium seedling disease. A lot of times down low in that root system is where you'd see it. And then here, just to emphasize those conditions favorable for it, here the water molds or with the Pythiums, the Phytophoras. This is these are both require that moisture and like that. Fusarium, Rhizoctonia like drier conditions. But again, you can see from this table why you would tend to have more problems with Pythium, and then later in the season, Phytophthora. And then some of you that have sandier soils or stress conditions, I've seen it with sandblasting or even hail, those types of things that stress. Sometimes Rhizoctonia can kick off in those scenarios a little bit later in the year. We do see other types of seedling injury, right? So we're going to talk a little bit about Alevo today. And how many of you have seen this little halo effect on soybean? Seen some of that? This is definitely one that it can be confused when we look at this, and we're going to just show you a picture of PPO injury because I have a student working on some of that with interactions with seedling diseases. But for sure, this is one that you can see with use of Alevo, not associated with any disease. Hasn't been associated with any yield loss. A lot of work has been done with that to see if there's any association with it. None's been identified. It's just basically that product, that AI, concentrates in those cotyledons and burns. Okay, and that's where you tend to see that at that stage. If you go out the wrong day, you won't see it. The cotyledons will fall off sometimes. Here's an example here with just some different causes where you got some Pythium infections, some pre-emergent herbicide injury where you can get that burn with the PPO. One of the differences you can see here is you got some root injury here that's really white and clean down below. Okay, so as you're trying to differentiate this next spring, you can kind of see those different characteristics where you got great root system and damping off plants or injury above. And then those scenarios where you have some sort of root injury. Here's a Fusarium example with a lot of discolored roots, a lot down towards the tip. Here's Rhizoctonia with that upper lesion right there near the cotyledons. So one of the things that when we talk about injury too, if you looked at those conditions that were favorable for Pythium, those overlap just perfectly with our PPO injury. Anytime you get really wet conditions, cool soil temperatures, slow emergence, where you got more time for that contact burn to occur, then you start to see some of this work as well on it. So again, this is just to kind of emphasize that. We do have a student, I'm not sharing any of this data today, we're still working through it, but I do have a student that's working on PPO injury and to see if there's an interaction with seedling disease, because you would think maybe if you had all that injury that you could have more seedling disease. I actually have two hypotheses I'm working on. One is, does anybody know about white mold and systemic acquired resistance with cobra? So you spray cobra and you induce the plant to be more resistant. Everyone's told me, oh no, that doesn't happen in soybean with these PPOs. And I said, well, how do you know? Because we've got it in this other one. So, and I actually have some sites that would suggest this, but I'm waiting until I summarize everything to see. But that's one hypothesis, that actually injury is a positive thing, and one is that injury is a negative thing. So, you know, as far as its potential for disease. We're still working through that, and you should see that coming out here within the next year for sure, the students finishing up. When we talk about seed treatments, the first thing though I want to mention to you is your first line of defense on any of these fungal soil-associated diseases. So something like Phytophthora, for example, you know, your first one is using resistant varieties. That's the same way when we talk about sudden death. We'll visit that as well. But with that, you know, just make sure you're using a good source of resistance. Now we have another project that we're working on that we just started this past summer, where we're looking at different sources of resistance and then some of the newer seed treatments that are pretty good on Phytophthora. So historically, any resistance gene and high tolerance is your best combination, okay? So you're picking the higher tolerance score. Phytophthora is rated for 2 scores. How many of you deal with Phytophthora? Some of you, okay? So you got a tolerance rating, and then you've got a resistance gene, specific gene rating. So combination of those two is your best option, is what we see historically. A lot of diversity in this pathogen. So when we look across the state, you know, we see all kinds of it. In a given field, we can see several different biotypes, races, whatever you want to call them. And then always making sure you're increasing your fungicide. Traditionally, metalaxyl methanoxam, okay? And most seed companies today, with the combination products that they come out with, they've increased those rates to where you're going to have moderate Phytophthora control. Not the super high, but in the middle with it. Do want to share some data with you, just general. How many of you go to the Soybean Management Field Day Series? I see several familiar faces that do, so some of this you might get a little review here. See it twice, maybe you'll get it, maybe it'll hit a little better, I don't know. Maybe I'll describe it better this time. How about that? That might be the real thing. But looking at this, that series of studies or you know, field days, but they've got associated research with them. At the 3 years from 13, 14, 15, we had similar trials where we did these high input studies. And one of the things that we had in that were early season inputs. So just to kind of review, and we're going across our color bars here, and this is, I realize I don't have this is yield in bushel per acre. But in any event, no treatment, just as in-furrow fertility, a fungicide seed treatment, a fungicide and in-furrow, a fungicide insecticide, and then a fungicide insecticide in-furrow fertility. So the combination there is to really look at those different levels of inputs early on. Now, across all of these, and you can look at individual years, only in 2014 did we have any significance. So this is our non-treated, and I can tell you without letters that these 3 would be different than our non-treated in here. When we looked at across the 3 years, what we had the exact same product comparison, this is what we had. So we're going to look at no treatment, a fungicide seed treatment, and then what we'd say a complete treatment, a complete package. So fungicide treatment, insecticide, that in-furrow, or that early season, some addition to increase or improve fertility up front. So when we look at this one, you know, if we look at stand, in this case, looking at the early season count and late season harvest count, you can see, I mean, we get some differences in stand. And I'm sorry, I just realized this is plants per hectare. I converted my yield, and I looked at this quick, and I did not convert it. But in any event, I'm going to talk to you about populations on a different slide, so don't ditch that. You can see effects in stand when you use seed treatment, right? That's the bottom line. You will see that. You always see it in yield. On average across this, from no treatment to that complete treatment, you know, we're in a range of a little over 2 bushel, okay, on average. So is it worth it to add that extra treatment, and what consistently pays and what increases stand? So when we look at yield, maybe you've seen these types of comparisons, yield to stand comparisons. Did you have a population person talk this year yet? Anybody? Okay. Are you going to have anybody? Okay. I'm going to hit on it a little bit then. So many of you that do this know that stand and yield do not relate, right? So what's your optimum planting rate? And when we get into sudden death syndrome, we're going to show you some research from across the region that talks about identifying optimum seeding rates for economic return. But if your stand was important in all cases, these are just all our different sites, we need to expect to see some good relationship, right? I don't know, anybody ever go to a turkey shoot? I would do that. It kind of looks, the boards kind of look like this. It's not, but you don't have any linear relationship, right? It doesn't say that population directly transpires in or transfers into increased yield. And so that's why many times you can see seed treatment effects on stand, but you won't see them on yield, okay? Or it'll be very minimal or minor. So for those of you that are planting super high populations, and we're going to get back to this again, you're not going to see as much benefit from a seed treatment. When you reel your populations down, that's where you get into that optimum, because you're dealing with an interaction of population and that fungicide effect, and how much are you improving the productivity of each of those plants with the addition of that seed treatment, okay? We'll visit that again. So in the end, in this one, the best control or the best product was just the fungicide seed treatment, okay? Now, how much does an insecticide addition add to your cost? Somebody tell me. Fungicide seed treatment, fungicide, insecticide. Is it $1? Is it $2? Is it 80 cents? Depends. Not very much, right? I can tell you my research isn't going to show you that level of economic return from all this work. So you have to make that decision. But in the end, what we always show is that just the fungicide is where you tend to make your return. You don't have to have the insecticide. So the rest of that, based on our ability to drill in on these plots, which is probably, a bushel over a bunch of stuff, we can't pick it up, okay, when we look at it. Yeah.
Loren, what are you considering the planting date? Where are you at on planting?
Great question, Leo. So, and we know that, and the reason too, so everybody's on the same page here, that insecticide is going to really help with early season bean leaf beetle particularly, right? So typically though, we don't see the populations high enough that are doing that much damage. Now, if you got a lot of woodlots and you historically have fall heavy bean leaf beetle populations, personally, I'd put a seed treatment insecticide in there. When we talk about planting date on these though, it varied all over, okay? Earlier plantings tend to increase your chance of return with these, right? You're going into cooler soils. So I could definitely show you that. Over the years, I could show you examples of high soil temperature and still having seed treatment effects, but it would tend to be in a Phytophthora or heavy Rhizoctonia field. For all of you right here, cooler soil temperatures for the most part here, you're dealing with Pythium and Phytophthora. Okay. And also, I want to point out too, when we talk about, when you ask the question of planting date, I would encourage everybody not to think as much about date as soil temperature the day you plant, because that is kind of that critical, because we've had studies that were late April and the temperature was pushing, you're pushing 60, and then you go another year and you're in mid-May and you got, this last year, Mother's Day, we had it in our field, one of these sites in North Platte, they had snow on their field on Mother's Day. So, so think about your soil temperature. That's the biggest thing. So if you're going out there and looking at your forecast, that's what I pay attention to, and that's what I think about when I do seed treatment studies, is soil temp. But good question.
What's your optimum soil temp?
60 degrees is optimum, but you don't want to wait till it's 60 a lot of years, right? So, and if you were, the other thing to consider here, what if you were what if we had a really weird year where we got this cycle over 60 degrees on April 25th? Your risk of frost is really high then, right? So you got to put all that into your equation. But in that general window of when we're planting, it's going to be late April, first week of May, somewhere in there. That's your typical, what I would say, your optimum. How does that relate to what you would say, Tyler? on the overall production in that window?
Yeah.
Okay. All right. Any other questions before we go into just general SDS? We're going to touch on some of these same concepts. Okay. All right. When we go into SDS, every year, pathologists and in cooperation with all of our contacts in all the states, we kind of do estimates of yield loss based on all these different diseases. And for sure, SDS is always on the top or in the top tier of those diseases that cause yield loss when we look at it on the overall production scale. So it's definitely one. There's a lot of your checkoff dollars, I can tell you, going into research on sudden death syndrome, just like there is for Phytophthora, another one that you see a lot in with it, and cyst nematode. So those are kind of the three biggies in soybean pathology in general. When we look at this one, because of its very aggregated distribution in fields, I think this is one that you really have to do a lot of evaluation of that site before you decide how much you're going to invest in management, right? How many of you have a field that has this much or more in SDS? Okay. Less than this? More common? So what I see more common in Nebraska so far are much less than this. I would say in that 10% zone or less, okay? For many cases, but maybe somebody here has it. There are fields that have a high incidence or distribution level in the field. So again, it's because it's a Fusarium. You reduce that tap root. This is a fungus that infects at the early stages, okay? So that's where when we talk about seed treatment activity, it can have activity. And then it's latent. So it's there, it's infecting. And then after that, when we get moisture later in the season, during flowering is typically what triggers that really to kick off. You get more infection here. You got a lot of lateral root development above. And then if you go inside here, you'd see that discoloration at the crown and kind of running its way on the outside with it. It is one of those that we would say, stem and root rot diseases, those that you tend to see really having a high impact in that mid-pod fill stage. So we hit R5 to 6. That's when we're in that full seed filling stage. That's when we typically see this show up. The key with it is it happened much earlier, right? So when we look at the life cycle of this, it's going through, and then as far as it's, in that soil temperature 55 to 65 is kind of optimum. So when we talk about earlier planting in management, if we talked about avoiding early planting, that's why we would say that, okay? Yeah. Okay, so residue it overwinters and it can colonize corn and it can exist on corn. There was a study at Iowa State that showed corn kernels could have it in it. I had a question this last year because of a lot of down corn. How much of that could that increase your risk of SDS? Theoretically, yes. From a pathologist perspective that grows inoculum on grain, there's 8 million other things could colonize that corn just as effectively and would be competing with it. So I would have a hard time believing that in and of itself would spike SDS, but it could. It can increase inoculum. The other thing to keep in mind is that this is a fungus that, well, we don't have a picture on here, but it produces what's called a Chlamydial Spore. So that's a very resistant spore, and it's the equivalent of a Phytophthora oospore. So when it's in soil, it can be fairly persistent. It will break down over time, but it's still there, okay? So once you have SDS in the field, you're gonna have it, but then there are things that can increase its potential or an amount of population in the field that can result in more, okay? So some of these things like a corn-soybean rotation that most of you are in, you're not gonna have much effect. Now, one question we get on survivalship is what does a cover crop do? Because there have been studies that show if you rotate wheat into the rotation, that helps reduce it. And I can't tell you the answer to that. Typically, the cover crop isn't bridging a full year, so I don't expect that, but I haven't seen any results specifically for it. So that way. I think that's all I got here. So what I wanted to share with you today for a little bit are some different projects that have been done. These are funded through your soybean checkoff dollars through the North Central Soybean Research Program. This is a larger study that we had some data in. It was coordinated out of Iowa State, so you see a lot of my slides here have Iowa State. The other one that you see on here is Crop Protection Network, and you can see and find a lot of great information on overall soybean disease and disease management on that site. That's a collective effort of all of us in the region. So when we talk about SDS management, one of the things that we talk about a lot is variety selection, and you can see that night and day response, okay, in variety. If you've ever done this, if you have a field with a lot of SDS, you put the more less tolerant compared to more tolerant, you're gonna see a response visually. Now, when this research group did this across several regions, now we didn't have this one in Nebraska, but they had these different areas at 10 sites where they had 3 different seed treatments, and they were looking at a base treatment fungicide, and that base with a levo at the low rate and a base at the high rate. And then they had 3 soybean varieties in there. Okay, and then they had those different ones, and I just pulled this data from the group because this is a moderately resistant versus a moderately susceptible. Here, our orange is our level of SDS, and they talk about disease index, this FDX. That's basically how much and how severe it was, the combination of those 2 ratings. And so, as you would expect with your susceptible one, you tend to see more SDS, and then you've got that corresponding difference in yield. So again, the first line of attack, and this is repeated over and over again, but I thought this regional set showed it very well. Use that better rated variety first. It's your first step. Same thing with Phytophthora, guys. Same thing. And then another study I want to share with you is a larger data set where they looked at using a levo. So we know that based on what's available for SDS, a levo is the only one that really has consistent activity. Okay. When in this study, they had a lot of different comparisons where they had some commercial base and then that plus a levo at the level for SDS. So this is the higher rate if you're managing SDS. And then we've got the disease index. Now here's this difference between a levo and that comparison fungicide base. And so you've seen these piano graphs before, right? A lot of people are starting to present it this way. But I like it because it does give you an idea of how effective these products are, right? If this center point is way over here somewhere, it's probably, if you're in the middle, it's pretty much a split. You can randomly draw stuff and get a bell-shaped curve. But if you're going left, you got a much better when you're looking at a positive response. So we know that a levo can work well in SDS fields. The key is, where does it work? Well, how much do you need to have it work? That's, I think, probably the bigger question. So one of the things they did with this data set is they looked at, what's that probability of breaking even on that investment point? And so with this one, they were looking at no disease. And so you can see if you just went out and tried to use it, not going to have a return. Are we surprised in that? Not really, right? Okay, it's very specific. Your other fungicides work on a lot of different things. This one is very specific for sudden death syndrome. So if you don't have SDS, not an issue. Now, if we went up to where we had a low level of disease, okay, now we're increasing that probability, right? So this is a disease score of less than 10. Okay, so that's going to be, it could be a fairly high incidence, but very low severity because it's multiplied, or it could be a very high severity and low percentage. But in any event, in plot work, this is what they would see. And then when we go up to higher, where you got a field with a lot of trouble, then you can see it's going to be, and as those higher levels, it becomes a really good idea. The question I have for you, and what you're probably wondering, is how much of that field do you need before you make that trigger? And I think that's going to be your decision at this point. I can't give you the answer for that. But I can tell you, if you've got a field that's got significant pressure, I would sure use this. But what that number is, I can't tell you. It's somewhere, I would say it's somewhere between, I would estimate that it's somewhere between 15 and 30, 40% probably to make it profitable. Because you are going to have some areas not affected that are in that zone. If you hear things about asymptomatic plants and yield loss due to SDS, I haven't really seen much of that. Okay, you got a pocket, probably hitting you in the pocket primarily. And we've got quite a few, even on farm research trials, that would suggest that as well. So that's the other thing related to this. If you want more data on some of the SDS work, you can go into, Tyler, do you talk about the on-farm research program some, I assume, at some point?
A little bit, yeah.
So, if you go in there, you can search out these studies and find sites where we did SDS work as well. But one of the things they did with this group as well was looking at different plant populations, okay? I'm pretty sure nobody in here is at 40, 60, or 80,000 plants per acre planting, right? It's pretty risky, right? We're not going there, and I'm not going to suggest that. But that's what they had. They had this, and then they had 100, they had 120, and they had 140. 3 seed treatments, no treatment, commercial base with the illegal rate, okay? This is their graphic of yield and seeding rate, okay? So when you go in here, we've got this non-treated, commercial, illegal. Now keep in mind, these are in fields with sudden death syndrome, okay? So we do have SDS in the mix. Now, if we take this and they do the analysis on it, and then they take economically optimum seeding rate, so what's the optimum seeding rate for return? And they did that comparison with the untreated commercial base and Alevo. $8 bushel, $11 bushel, average profit increase. I'm pretty sure there's some of you in here that are in this zone, okay? Not too many people below 120,000 seed per acre. But one thing that I do see, and it really depends on your situation, your soil. Some people here will say, well, I've got to have more because I get crusting and I need that to get up. I'd love to do some experiments to see if that translates into reality or not. I don't know. I think it can in some situations. But the reality is, I think if you look at this and you kind of can see how we dropped population to get return, right? And so that idea of reducing population to see the benefit of your seed treatment becomes more clear when you look at this data with the conversation points we had before, right? So again, you know, you can make a lot of investment in seed, and you can do it in number and you can do it in chemical, but the combination of both, you need to work through that a little bit before I think you get to that optimum point where you could get your maximum return with it. So here's some of the partners that help support funding that. So any questions on SDS? Anybody? Okay, all right. Let's talk about cyst nematode. So one of the things with SDS, when you look at management, you know, they'll come in here and they usually talk about SCN management, okay? And you can have SDS without SCN, and you can have SCN without SDS, but when you have the two together, it makes it worse. The reason for that is cyst nematode goes in, migrates into that root system, starts feeding, and when it's feeding, it's producing a wound, right? And you can have infections, and you can have that manifest into more disease. So managing cyst nematode is part of that SDS package, and then just in the event that you don't have SDS, but you're managing cyst nematode, I want to review that a little bit and look at some seed treatment work that we've done in the past. Excuse me. So this was last year's ad for Chlamydial Complete, and I'm okay with all these, but this fourth one is, treat soybean seed with a seed treatment for cyst nematode. And the thing that I would ask there is, let's look at the data and see if that's always a valid point from what we have. Okay, these others we know. This is all great stuff, but this is the one that I personally would call a question about. And we do have the soybean sampling program through your checkoff dollars funded. So if you have taken advantage of that program, if you're 5 years from when you sampled your field or 6, I encourage you to do it again about every 5-6 years. You don't need to do it every year. Had one consultant out west was sending a bunch of soils every year. Talked to him one year and I said, hey, you send us a lot. Are those all different? Oh no, we just sample the same field every year. Well, you really don't have to do that. Okay, you don't have to do that, but you can every 5-6 years to get a check and see what's going on with it is a good idea. But again, that's a free program. You can contact Tyler or myself. We can get you the bags and you can use that. You put the soil in and we give you the results. If anybody here over the course of this program, we've had, I think, 2 samples lost. So if anybody here sent something in and didn't get a report, please let me know right away. So you're dealing with numbers, anything can happen. So don't want you to think we're doing a bad job on that. The thing that we talk about with management, when you identify cyst nematode in your field, is that rotation component of, a non-host, most of you in a corn soybean rotation. If you do this non-host crop 2 years, you do reduce your population more, but it's not twice as much reduction. Okay, your first year can range anywhere. I had a PhD student work on this, and that first year rotation breakdown in population could go from 90% to like 5%. It depends on the soil and what's going on. So any of you that's seen, I had a grower send me a clip of a ad for some sort of a forage reddish or something, and it said reduces SCN populations up to 90%. I said, you know what? I got data that says corn does the same thing. So when you see that up to, be careful. Here's your but just normal rotation. And then we talk about rotating resistant source, and that's a totally different topic that's very difficult to do, but most of you are going to grow 88788. This is a great table. I just borrowed this from Greg Tilk over at Iowa State. He does a lot of cyst nematode work. He put together this last August. All of these aren't viable today, but these are all the different products that you could use. So Nimistrike was pulled by Monsanto. I'm not sure of what its future is at this point today, but these others are all products that you could use. Now, of the ones up here, data-wise that I'm going to talk to you about that I have, I'm going to show you some Chloriva, and I'm going to show you some Poncho Vetivo on beans. And then we can talk about Illevo from a standpoint. We do have greenhouse studies that you can show that Illevo is a direct effect on the nematode. It's not, you know, it's a chemistry that is active against nematodes. It's actually marketed in other markets as nematicides in like bananas, for example. So it is something that has direct activity. It's of the same, not the exact same MOA, but activity from like a Victa when we would do a Victa studies, which isn't very common on the market now. But when we would do a Victa work, we'd have that same thing. It's got a direct effect, you know. So historically, if we rated these, we did a lot of work over the years with a Victa, Poncho Vetivo, and then Inhibit. And in all of those from a regional study, we would rate a Victa as the most active, and then Poncho Vetivo, and then Inhibit. Because Inhibit is actually this harpin protein that's going to boost that natural plant defense, coming into that SAR, or systemic acquired resistance arena again, where you got to have a lot of stars aligned before that happens. Okay, it doesn't happen every time. So that frequency of occurrence and how it works, that's how I would rate them. So if we looked at in the particular case when we're looking at, here's just the Illevo to remind you that when we're talking about nematodes, we're at the half rate compared to the full rate for all the sudden death syndrome stuff. When we look at biologicals, how many of you have seen, you've seen a lot on biologicals in the last year, right? Last 2 or 3 years, right? Coming more and more and more. So I just want to share with you this morning a data set that we had. This is a couple years old, but where we looked at 2 biologicals. We looked at the Pasturia, which is a direct parasite of nematodes, or the cyst nematode, and then we looked at Bacillus firmus, which is that's the Vetivo part of Poncho Vetivo, okay? And this one really works in producing a film and colonizing the root system, which is the same mode of action as some of these other products that you're seeing. You see Bacillus in general in the AI, it's some sort of root colonizer. It may produce a byproduct that inhibits egg germination or chemolocation of the root or something, but it's some sort of a film. It's going to colonize that root system in general. And in this particular study, we did it a couple years where we had the base fungicide that was the same in all of them, and then the microbial agents we had were the Chloriva or the Poncho Vetivo. So we did have that base fungicide that was the same in everything, and then just the difference were those 2 microorganisms. Okay. Now we had 4 sites. We did 8 replications instead of 4 because we're trying to tease out small differences typically with this kind of stuff. Stand counts, yield, and populations, initial and final. In my mind, if you're having an impact on SCN, you should be showing something up here in your overall development through the season if you're going to have an effect. 2014 and 2015 is when we did this work. So here's our yields at the 3. We did 3 infested sites, 1 non-infested site each year. Really didn't see any treatment effect when we looked across these for actually what was going on. Now you can say, well, we got some trends here. Well, trends is just the fungicides higher. Here's our Chloriva, there's our Poncho. So you can see just the fungicides higher. If it is, this one Poncho Vetivo is just, I mean, there's no way that's statistically different, right? Over here, similar, up a little bit, up to here. Interestingly enough, in 2015, our infested sites yielded more than our non-infested sites. So a question comes to point, well, what's your population levels? Doing cyst nematode studies, what's that? Well, let's take a look here. Well, in this year, we had 4,300, 1,000, 2,500. These are average spring egg populations. And then if we jump to, in the other study, we had 260, 355, 2100. So I'd put these two as much lower to where we might see some of that type of response where you don't see as much of a reduction in that. So this was our better test year, I would say, than this one. This site, really good with the higher than 2000. Most of you in this room, if you have cyst nematode, though, I'm going to tell you, I bet you're in this 1,000 to less if you've been managing this beast for a while. So you're not going to be in this 4,000. If you are, you've got a significant problem that you're coming down from probably. But in general, if you're using resistance, you're rotating and you're taking care of it, you're probably going to be in this 1,000 or less. And I can tell you that one of the reasons we always did cyst nematode field days, and one of the reasons I really didn't want to do those anymore was trying to find that site that had 2,000 nematodes right by the road that we could do that field day. That was driving me nuts. So anyway, with it. So that's kind of what you can see from a standpoint of overall population levels. And I can tell you at the end of all this analysis, we didn't have any significant population response when we looked across there with those products. So really just, you know, the way we're seeing that work out. And actually this is, and I'm sorry, I need to explain this better. So this is reproduction factor. So this is fall population minus spring population. And so if you have an RF over 1, which you see you can have in a lot of your products, you're going to have some level of reproduction. Now the reality is, even in here, where you do see, I said statistically we didn't have any effect, so you got a 1.5 versus an almost 4. I can tell you there's so much variation in a system that unless this gets to like 6 or 10, we won't show any difference. And this is again with 8 reps. So while you do see some, with these populations, you do see some trends that can occur, overall, we didn't see any results. And this is our acid test versus our low population. And then here's our higher one, okay? So you can see some trends, but overall, we don't see it as a positive response that way, okay? Now, can it work? Yeah, I can show you specific sites that, yeah, it worked, but it's really up and down, so it's not an across the board. Here's another set of data. This is from Greg Tilka as well. He did a lot with Chloriva Complete, so the Chloriva compared to just that Cruiser Max. So here's his fungicide composition with and without Chloriva, okay? And when he's looking at here, you know, we're showing the benefit with Chloriva. You know, he's got almost up to 5 bushels. These are sites where he had statistically significant differences in positive return. So he does have some sites that worked. And then here's some negative positive returns. But anyway, in this event, I mean, it does look like it's improving yield in some of his sites, right? I mean, it is. You can't say it's not with this type of thing. In his location, his average return 0.6 bushel, okay? So that's on average across the sites. So again, this is another tool. You can look at these nematicides. You can look at all these different products. I think you got to really identify your site and know that specific history. Look at it as an individual field location, not your whole operation, right? And how important it is to have these different products positioned there. You know, when we talk about planting date, people ask, I say early planting. I don't discourage you to not early plant for SDS if you're dealing with SDS, but just plant that field last in your series if that makes sense, because days make a difference in our research studies. So if you're planting in, you know, whatever week, from Monday to Friday is a huge difference, okay? And will really make a difference. If you're reducing seeding rates, that's the other part. You know, I would really encourage you to use that seed treatment, at least the fungicide part. And that's the part that you need to really protect that seed, unless you're in a situation that you think you're going to have significant insect pressure, okay? And again, cost becomes into this as well. So sometimes it's easier to not worry about it and just do it, but it really depends on your bottom line and if you need it or not. We need really, for Nebraska, I think you need more data on how much of the field you need to make that decision. So if you're dealing with SDS, I would say over 10%, somewhere in there, before that's going to become a profitable venture for you, just from what I've seen. But I really don't have a number to tell you. We had a student in biosystems engineering that was working with a specific, this multi-hybrid planter that she could plant treated seed and non-treated seed. And I thought, well, that's going to get at it, but we got a lot of work to do before we can take that data set and tell you a percentage. So I'm not close to tell you that. But with that, so and then Chloriva would be, you know, really just a response. You know, you have to have cyst nematode. So if you don't have cyst nematode, you don't really need to position those types of products to show good response for any. You have no reason. So with it, do have different sources here for more information for you. I am out there. I got a Twitter now. So follow me at MulletManLG. That's it. It shows a little bit about my character, I think. So I'm going to keep it. I thought about changing it, but I'm not going to. So anyway, and then we also have a lot of, this is great, you know, winter weather video arching here. Little disease videos on all our different soybean diseases funded through the soybean board. So any questions? All right. Very good. Okay. Well, you're welcome anytime. I don't know. I haven't started chasing them yet. I chase about everything else, but I haven't chased those. So